Given a rational function f of x equals to p of x divided by q of x, where p of x and q of x are polynomials, and the domain of f of x is all x for which q of x is not equal to 0. If x minus a is a common factor of p of x and q of x, then the function f of x has a whole at x equals to a. For example, f of x equals to x squared minus 16 divided by x minus 4. For this function, we can write the numerator as product of x minus 4 and x plus 4, and the denominator x minus 4 remains the same. We have a common factor x minus 4. This gives us x plus 4, and x is not equal to 4. The domain of f of x is all x with x not equal to 4. Since x minus 4 is a common factor of the numerator and denominator, f of x has a whole at x equals to 4. Graphically, f of x equals to x squared minus 16 divided by x minus 4 is a straight line x plus 4 with a whole at x equals to 4. Vertical asymptotes. The line x equals to a is a vertical asymptote of a function f of x if, as x approaches a, f of x approaches plus or minus infinity. For example, f of x equals to 1 over x minus 2, the graph of which is given here, has a vertical asymptote at x equals to 2. As x approaches 2 from the positive side, the function f of x goes to positive infinity, and as x approaches 2 from the negative side, the function f of x goes towards negative infinity. Locating a vertical asymptote. Given a function f of x equals to p of x divided by q of x, with q of x not equal to 0, a vertical line x equals to a is a vertical asymptote of f of x if q of a is equal to 0 and p of a is not equal to 0. For example, consider the function f of x equals to x squared plus x minus 6 divided by x squared minus x minus 2. Rewrite the function f of x in fully factored form if possible. Let the numerator p of x be x squared plus x minus 6 and the denominator q of x equals to x squared minus x minus 2. Now write p of x in fully factored form if possible. X squared plus x minus 6 is x minus 2 times x plus 3. Similarly, x squared minus x minus 2 is x minus 2 times x plus 1. Now rewriting f of x, we have f of x equals to x minus 2 times x plus 3 divided by x minus 2 times x plus 1. Now cancelling out the common factor x minus 2, we have x plus 3 divided by x plus 1, where x is not equal to 2 and x not equal to negative 1. The domain of this function f of x is now all x except x equals to 2 and x equals to negative 1. Writing the domain in the interval notation, we have the following. Since x minus 2 is a common factor of p of x and q of x, the function f of x has a hole at x equals to 2. And since q of x is equal to 0 when x equals to negative 1 and p of negative 1 is not equal to 0, we have a vertical asymptote at x equals to negative 1.